So, I've been tweaking on settings with this. This is like my fourth time trying this. I'm trying to keep track of my progress. So this is the first time. I hope this stream is dialed in, because last time it was all skippy and then we had different problems. Now, hopefully we don't have any problems. And let's get started. So what I want to do today is I want to study folds again, I want to break down the theory of folds, because I don't think you can study without reference, and I can't be bothered to go get reference right now. But let's go ahead and talk about it. So I'm going to go ahead and use the darker pencil, make a big pen. I say F-O-L-D-S. So we're doing folds today. We're going to put up that, or just keep that back there so that we know what we're doing, because we are easily distracted. Okay, so folds in clothes are a physical anomaly, and so the best way to talk about these in 3D, folds in 3D, is we should start with 2D. And so if we have let's do something flat. So in 2D, so in 3D, cloths are like a two-dimensional object, right? So in 2D, cloths will be a one-dimensional object, and if you understand dimensions, you know that a line is one dimension, right? And let's just assume that in this one-dimensional world, gravity is down, right? So why would gravity be up? I don't know. Maybe we're in Australia. But in this case, we are above the equator, so gravity is down. And here we go. We know that gravity acts on all the parts of this cloth downward, right? So if we imagine we have an anchor point, such as like a stick sticking out of the ground there. Go back to our red color, whatever we had. This is a different red color. Maybe I should save a palette for this. Anyways, never mind. This stuff's going to fall down. What's going to happen is this part is going to hit right here first, but all of this stuff is going to keep falling, right? And it's going to be exactly this length the whole time, right? So as it falls, this length is going to fall like that. This length is going to fall like that, right? So what you're going to notice is, if we take these 2 points, this point and this point are going to compress together. Their distance will reduce, and it will create this kind of parabolic shape, right? So that's the first part of folds. This is folds in 2D, right? So when we think about that, let's try to move that on. Let's change this over to a 3D environment. So we're still going to, instead of having a two-dimensional shape, we're going to have to imagine we have or instead of having a one-dimensional shape, in 3D we would have a two-dimensional shape that I have to obscure, right? And we're also going to go ahead and make sure that we do have, just like these points, we have these points at each of the edges, right? At each of the edge of the one-dimensional areas. All these are called vertices, right? So we'll just say that all of these these are all vertices, and I'll try to use that word to describe these things. And we know that if the vertices converge, or the vertices will, I don't know, let's just experiment with it. So let's take this green that we had for this. Instead we're going to have a little podium, and we're going to imagine that this is here and that gravity still acts down on every part of this, right? So what's going to happen is this point, which would have been right here, down to right there, right? So we know that if this is stopped, that these are all going to go together. But keep in mind, that means that this is going to be the top, and these are all going to fall towards that middle, the same way that these all fall to that middle, right? So we now have this, but here's the problem. Now we have to deal with this interaction over here. This interaction, right? And that interaction, if these are all going to come together down here, we're going to have, let's go back to our green, we're going to have jupe, 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 right? What happens when we compress this? This is going to get compressed, right? And what happens, and let's go to a purple color down here, is if you have these two things, right, and they're too far apart, and then we push them together, imagine this going into here, and this side going into here. This is going to, we still need to account for all of this, even though this is here, so it goes, right? Probably going to be something like that. So when we have this, what we have to account for is that this, between those two things, you have to have this much space, right? So you will have to have this much of a difference. They might even push each other away because of the resistance, right? And if we go back up to here, this comes down here, and it will go down towards these and meet up at the edge, right? Well, probably right there. And so you'll have something that looks a little like this because of the compression. Maybe it'll have some different qualities, but this has compressed down to da-da-da-da, da-da-da-da, until it's all compressed like that, right? As it's going downward to meet there, because all the things want to do this. They want to go towards that center because they want to go to the lowest part they can reach. It's being suspended because of that, right? And so that's what that fold winds up looking like, right? It needs to compress, and there you go. That's a thing hanging on a thing. So what we're going to call these, thingies, this is going to be the point of tension, and these are going to be our corners, right? So that's cool. We're going to have a single point of tension, and everything else is going to be slack. Then you are going to have some, I'm going to call that compression, because all of that material needs to come together, right? And that's why it kind of fluffs up here, because the compression just doesn't happen down here. It also happens at every stage on the way up. There's less material, but it still has to compress up until it gets up here, right? So that's why we have this long, consistent fold. And it kind of turns into a triangle because it's going to taper out because there's going to be less compression until there's not enough material to compress right here. Now it's tense, right? So it pulls straight lines. Cool. That seems like a good start. So that's our first lesson with the folds. And I'm just going to see, this was live for, I don't know, how many minutes? A couple of minutes. Didn't drop any frames. And I don't want to put so much effort into exploring this if it's not going to work yet. So if it worked, it worked. Okay, so that's our first try. Thank you for watching. Hope this helps you understand how I think about